हम तक पैसे? No more. At Spring Library, we explain every topic in simple way. Join the learning family and score high every day.
For this problem on the topic of kinematics in one dimension, we are told that simultaneously two stones are thrown, one straight upward from the base of a cliff and the other straight downward from the top of the same cliff. If the height of the cliff is 6 meters and the stones are both thrown with the speed of 9 meters per second, we want to find the location of the point where the stones will cross paths. Now the initial velocity v0 is known for both stones, as is the acceleration a due to gravity. In addition, we know that at the crossing point the stones are at the same place at the same time t. Furthermore, the position of each stone is specified by its displacement y from its starting point. And so the equation of kinematics that relates the variables in question is y is equal to v0 t plus a half at squared. So we can apply this equation to each stone. We have the displacement for the stone moving upward, y up, is equal to v0 up times t plus a half a t squared. And for the stone moving downward, yd is equal to the initial speed of the downward moving stone, v0 d, times t plus a half a t squared. In these expressions, t is the time it takes for either stone to reach the crossing point, and a is the acceleration due to gravity. Note that y up is the displacement of the upward moving stone above the base of the cliff, whereas y down is the displacement of the downward moving stone below the top of the cliff. H here is the displacement of the cliff top above the base of the cliff, as we can see in the drawing. Now the distances above and below the crossing point must add to equal the height of the cliff. So y up minus y down must equal to h, where the minus sign appears because the displacement y down points in the negative direction. If we substitute the two expressions for y up and y down into this equation, we get that v0 up times t plus a half a t squared minus v0 d times t plus a half at squared is equal to h. And then we can solve this equation for t to show that the travel time to the crossing point t is h divided by v0 up minus v0 down. If we substitute this into the equation of motion, we get that the displacement y up is equal to v0 up times t plus a half a t squared, and this is v0 upwards into the expression for the time, which is h over v0 up minus v0 down plus a half a into h divided by v0 up minus v0 down all squared. And so now if we substitute our values in, we get this to be 9 meters per second into the height of the cliff, which is 6 meters, divided by 9 meters per second minus 9 meters per second plus a half times the acceleration, which is downward and hence negative, 9.8 meters per square second. We suppress the units here, all multiplied by 6 meters divided by 9 meters per second minus 9 meters per second. And so calculating, we get this distance to be 2.46 meters above the base of the cliff.